Hi there and welcome. My name is Rebecca Weaver. This is Chapter 9. We're looking at techniques of integration in our applied calculus class. Section 9.1 is integration by substitution. We have several differentiation and integration formulas that we're going to be looking at today. So we have set up in a table the differentiation formula and the corresponding integration formula. So let's look at those. The derivative as if we have x to some power r with respect to x is just r times that x raised to the power r minus 1. So when you go backwards with that, don't forget to add that plus c because that constant could have been there for any one of those answers. It's nice when you take the derivative of e to the x, it's just e to the x. So when you do the integral, it's just the same. Looking at natural log, the derivative of the natural log is just 1 over x. So if you're taking the integral of something where it's 1 over x, you'll know that that answer is natural log of x. Derivative of sine with respect to x is cosine, so that makes sense that the integral going backwards, the integral of cosine is sine. The derivative of cosine is negative sine. We're not going to be looking at these trig functions. I probably should have taken these off here. I just used my regular slide that I had set up for Calc 1, so you can eliminate all of these trig functions here because you're not going to use those. If I have the integral of f of g of x, where I have the derivative of g sitting outside, kind of this is the backwards chain rule, I can say that this is the integral of f of u du. So we're going to say that this is integration by substitution. I'll go through some examples to show you how to do that. So if I have the integral of f of u du, then we just say that it equals that antiderivative with respect to u, and then you'll just plug that substitution back in when you get finished. So in doing integration by substitution, step 1, we're going to define a new variable. We get to pick what we want to substitute, and then we see if it'll work. It's just a way to make the integration easier. Sometimes you'll pick the wrong thing, and if you do, you just start over. So if you choose the wrong g of x, it's okay, just start over. So where g of x is chosen in such a way that when it's written in terms of u, the integrand is simpler than when it's written in terms of x, allowing us to integrate it. We transform the integral with respect to x into an integral with respect to u by replacing g of x everywhere by u, and we got to make sure that we have that g prime of x dx, replacing that with a du. We'll integrate the function with respect to u, and then we'll rewrite the answer in terms of x by replacing u with that g of x. So all of that said, let's just do this. So we have an example. Determine the integral by making an appropriate substitution. So we have the integral of x squared plus 2x plus 3 all raised to the 6. And then we have it multiplied by x plus 1 dx. You know, I don't want to multiply that all the way out just so that I can integrate it. So we are going to let u equal what's inside that main function. So we're going to let u equal x squared plus 2x plus 3. Because if I take the derivative of this u, take the derivative of both sides, I get that du is 2x plus 2 dx. Now, I can see that du equals 2 times x plus 1 dx. What I need to do, because I have an x plus 1 up here, see this x plus 1 sitting here? I have that x plus 1. So what I'm going to do is I'm going to make it look like that because I want it to read x plus 1 dx. So I'll divide both sides by 2, and so I have 1/2 du is x plus 1 dx. I'm going to take this right here, this x plus 1 dx, and I'll substitute in for it 1/2 du. So look at what this then becomes. It becomes, there's my u, x squared plus 2x plus 3. So it becomes u to the 6. Then this x plus 1 dx, that just becomes 1/2 du. That's easy to integrate. I just bring that 1/2 out front, make that 1/2 u to the 7th over 7th, and then I just replace it back with that x squared plus 2x plus 1 over 14 plus c. And that's it. So let's do another one. Determine the integral by making the appropriate substitution. Now this we don't have to go all the way through. They just want you to tell them what the integral is if you do a substitution. So we're going to go deep inside and let u be what's inside. So here we go. U is 1 over x plus 2. So now I need to figure out what du is. So I take the derivative of that, and I see that it equals negative x to the negative 2 dx. Okay, so that's pretty cool. That means that negative du, just rearranging this a little bit, negative du is x to the negative 2 dx. See this x to the negative 2 dx? I'll replace that with negative du. So here's what we have. We have the integral of 1 over x plus 2 raised to the fifth times that x to the negative 2 dx. Do my substitution, and this is what it looks like, and then I can integrate it. And when I get finished, oh, they do want me to finish this one. Okay, so I forgot that I finished this one. So that ends up being negative 1 over x plus 2 raised to the 6 all over 6 plus c. All right. And that is all we have for this particular section. Now, if you have any questions, be sure and email me, rweaver10@alaska.edu. Thank you and have a fantastic day.